Hello my dear friends, welcome to our program for science third prep stage. Today we have an important session about lesson 2, graphing the speed, the relation between distance and time and the types of each one of them and how can you calculate the speed from the graph. Let's go to start our session today. Here we have graphing speed and acceleration, the meaning of each one of them and the graph of each one of them. The speed graph, distance and time graph. What's meant by distance and time? Distance, it's the actual path, okay, that moved by or covered by the body in the street, for example, or each way. And we have the time here that measured by second. It's a period of time that taken by this car or by this body. So press play like this. We have a distance here, curved slope. We see this in the last session, but what's meant by each one of them? Curved slope, it means what? It means the part of the graph, the object moving at non-uniform speed. And we know about the non-uniform speed, it means not equal distances in not equal time intervals. So this curve, it has a curve shape. It means it is not uniform, it's not regular. So this one, it is non-uniform speed in this part, from the first one or the first point here, 0 to what? About 20. And we have another one from 20, and we have 25, 30 until 35 seconds. It has a straight line shape. So straight slope, it means a straight line of the object moving at uniform speed. And we have uniform, it means regular speed, equal in each period here. If you calculate it, we have the same amount of this or same value of the speed. So, and the last parts, we have no slope. No slope, it means what? It means we have no motion, we have no relation. It's what the measuring here or the distance here, about 1000, and it is still 1000 during time, without moving, without change, without increasing or decreasing. And we have no slope object, it means stationary. Here in this part here, in the slope here, no slope, it means body at rest. So the body or the car takes what? Take these 3 points here to what? To be rest or to stop. So the stop here, and it moves or it still stop during time like this, during 50, 55 and 60 seconds. So here this is what it means. What it means, the object as what? At rest. So after that we have another one about these graphs. So the speed here, how can you make your graph? Here we have many things here. We have A, B, C. This is the points here, and I need to make my own graph. My own graph for what? For uniform speed, for example. So here I leave A in 0.0, and we have B, for example, like this. Here it's what? It's 3 and 30. And we have here, this is 6 or C. I take it from 6 here, I take it like this. We have here, we have this one, 60 and 6. So these parts from A to C to B to C, this is what this is represent. What represents the graph or distance time graph that represents what? Regular speed, uniform speed. Why? To calculate it, we have 60 divide 6, it equal 10 meter per second. And we have 30 divide 3, it's 10 meter per second. If I have another one, for example, if I have, for example, here we have 8 like this and 80. So here this is also still straight line here, and it's what? D, like this one here, 8, and we have 80. 80 divide 8, it means 10 meter per second. So this is the first part about what? About the time graph or distance time graph to represent the uniform speed. And if I need to to make the body at rest, it means like this. I have like this, and we have another part like this. So from B to C to D, here we have the body here that moves. No, it doesn't move. Why, mister? Because we have here, this is 80, 80 meters, and we have B at 3. So we have C at 80 meter in what? In 6 seconds, and 8 seconds at still at 80 meters. So it needs what? It means all points are at the same distance, so it is the body doesn't move from its spot, from its place, from its position. So we have another one. We have here, this is C. For example, if I have this one like this, what's meant by this? And we have E, for example, here, okay, like this. Here we have different zigzag. So the zigzag here, it means what? It means this part like this, it has no equal distance and no equal time intervals. So it's represent what? By zigzag line or curved line or any shape like this. So it's called non-uniform speed. So non-uniform speed, it's different speed, different distance in different periods of time or different time intervals. That's represented by what? By this graph. For example, we have here, this is 80. 80, it's at point B. We have 80 meter that covered in 3 seconds. So we have in 6 seconds, we have what? We have 40 meters. It means it moves from 80 and moves like this. It decreases its speed like this from 80 distance during time to what? To the C, and increase like this again and decrease again. So we have different cases here. And if I have in less time, we have F like this. So I move it like this here. So in these 2 points E and F, it's the body. Yes, very good. It's body at rest. Okay. So we have different shapes in the graph to represent what? To represent the speed graph, distance time graph. So we have calculating the gradient. What's meant by gradient? It means a slope. How can you calculate the speed from the gradient? As we see, we have the slope of a graph is called a gradient, or the gradient, it means the slope. So the gradient of this line in a distance time graph equals the speed. So what's meant by this? We have this shape. We have, it's difficult to calculate the gradient for graph because its line is curved. So we have the distance and time. And after that we have another one, simple graph, or the straight lines here. It makes what? It makes the making it's easy to calculate the gradient. So if I have two types like this, one of them is curved and the other one is straight line, so it is very easy to calculate the straight lines, only to making it's easy to calculate the gradient. So I make the graph nearly the straight line here. So what is the speed of the object between point A and B like this? So here we have the straight line, and we have the first one from 0, 0. This is the point or the rest point. Here we have this 0 and 0 here, 0 time or 0 second and 0 meter. It means rest point or starting point or original point. So I need to calculate the speed of the object between A and B. 2 points here, A and B, and I take the slope. Slope, it means what? I take this part, its y-axis from B, from here, from 10 to 70. It's equal what? 70 to 10. It's equal what? Equal 60 meter. So the body moves 60 meters. So 70 minus 10. And after that, we have it took 3 seconds to move. So we have 6 minus 3. Because what? Because we have from 3 to 6, it's what? It is the time taken to move this distance. 6 minus 3 equal what? Equal 3. So we have this in this object. It has moved 60 meters. 70 minus 10, and we have 3 seconds. 6 minus 3, and we have the speed equal distance divide time. And we have the same rule. Distance divide time in all cases. 60 divide 3 equal 20 meters per second. I calculate this one from the graph. It's very easy to calculate it. Again, last time, I need to calculate this one. So we have y-axis and divide x-axis. What's meant by y? It means distance. What is meant by x? It means time axis, time by second. So it took 3 seconds and it took 60 meters to move. 60 divide 3 equal 20 meters per second. After that, we have another one. We have here the speed time. It's the gradient goes up and the object has a positive acceleration. And we have a new concept here. We have acceleration. What's meant by acceleration here? And the gradient goes down. We have speed and time. And we have the first one, we have distance and time, so we have speed and time. Speed and time, we have another concept that's called acceleration. What's meant by this? First of all, if the gradient goes up, the object has positive acceleration. And we have the second one. If the object moves down or the straight line moves down from up to down and the gradient goes down, it means the object has negative acceleration or deceleration. The gradient in this line in the speed time graph represent acceleration. What's meant by acceleration? What's meant by this concept? What are the types? So we have many things about this. So the speed time graph, what about it? What does the gradient here, the speed time graph show? So this one is show another new information. So play here the straight slope, and we have no slope, and we have the straight slope also like this. Straight one, straight slope up, so the object speeding up. What's meant by the speeding up? At uniform rate. So we have here increasing the speed like the car. We have many of speed in the car to increase the speed of the car during time. So we have this one straight slope up equal, or it means the object speeding up at uniform rate, uniform acceleration. And we have another one, we have no slope, the object move at uniform speed or stationary. Stationary, it means here, it means it must move because we have speed and time. So in this one we have this part or this no slope here, it means the body moves, okay, but by uniform speed. It is not rest point because we have speed here. If I have speed and we have a time like this, it makes what? It makes a relation between them. Speed here, it must move like this. The body moves here and during time. And what? And or by what? By uniform speed here in this slope. And the last part here, we have straight slope down. So it means what? It means the object slowing down at uniform rate. What's meant by this here? It means the deceleration. And we have another one, or the last one here, the slope or no slope, object moving at uniform speed here at 0, so it is body at rest. Because we have here 0 speed, 0 meter per second, so we have nothing about this. So it moves or it's rest during time, it stop during time. In 55 seconds and 60 seconds, this car, it doesn't move. This car was stopped. So this is the parts of our graph. Don't forget these parts because it's very important to you to understand the meaning of a speed time graph. We have a concept that called what? That called acceleration. Don't forget this. And I need to calculate the speed from graph. Here, for example, what is the speed shown in this distance time graph? We have here 8 and we have 8. So the last point, and here we have 7 and 7. And here we have 6, 6, and 5, 5, 4, 4, and so on. So what is the speed? Or what is the speed of this part here? 8 divide 8. It means 1 meter per second. Very good. Why? Because here it's 8. In this point here, it's 8 divide 8. Distance divide time. Next one. We have our speed shown in this distance time graph. I need to calculate the speed. So it is very easy. 8 divide 4, it means what? It means 2. Excellent, thank you. After that we have next. We have 4 divide 8, it means 2, mister. No, it's wrong. 4 divide 8, it is not 8 divide 4. It's 0.5. Excellent, thank you. After that we have next. Who can tell me? What about these parts? It's 5. All parts is 5. What's meant by this? The time distance, and we have time distance graph here in this part. It's called body at rest. It means 0 meter per second. Excellent, thank you. So we have well done. After that we have another part about the speed and acceleration concept. What's meant by acceleration concept? it's related to speed. If I have increasing of speed, we have acceleration. We have decreasing of speed, we have what? We have deceleration. After that, the meaning of each one of them. The acceleration of an object that measure how quickly the velocity or the speed change. We have another word here, velocity, and we talk about this one in lesson 3. So we have the train. It's accelerate. Accelerate, it means change its speed or increase its speed during time. So the accelerate in the straight line from rest as it does. So its velocity increases. It means accelerate. Accelerate, it means it has an acceleration. Another part we have here in this bike or motorcycle, we have this driver that move very fast. So the brakes, he used brakes. So the brakes here on this motorcycle are causing it to slow down. So this is negative acceleration or deceleration. So we have increasing speed, it means acceleration. It means change the speed during time. The whole meaning of acceleration like this. This is the definition. And if I decrease the speed during time, it means deceleration or negative acceleration. If you need to know this one, study it very well and try to understand it with us. So we have another example. A hungry cheetah spots a gazelle. So we have this deer like this. So, and this decided to chase it. The cheetah accelerates, means increase its speed to catch it, to catch the gazelle, and accelerate at 10 meters per second square. What's meant by second square here? It means the measuring unit, meter per second square, in the measuring unit of acceleration. So from rest until it reaches 20 meters per second. How long did this take? How long this take? It means I need to calculate the time of this cheetah to catch the gazelle, to hunt this gazelle. And we have the answer about it. We have this answer. Acceleration, it means, the meaning of acceleration, it's change in speed divide the time taken. It takes 2 seconds. How come? So here we have the change in speed and we have the time taken, change of speed, divide the acceleration here, equal what? Equal 2 seconds like this. 20 meters per second square, divide 10 seconds. So we have 2 seconds like this. Why? Because change of speed here divide the acceleration. Acceleration of gazelle, of the cheetah, it's equal what? Equal 10 meters per second square. And the change of speed, okay, it's 20. 20 it means what? Means the speed of the cheetah. So here this is 2 seconds to catch the gazelle, to eat it and to hunt it. After that we have another part like this about the acceleration also. Definition, the whole definition of acceleration, it is the change of velocity in unit time. What's meant by velocity? It's nearly equal speed, but we have two difference between them. So we talk about the velocity in lesson 3, okay? And after that we have acceleration again. It's the change of velocity in unit time. It means what? It means I change, increase or decrease the velocity or speed in unit time, in 1 second, in 2 seconds, in 1 hour, in 1 minute, in any one of them. So the measuring unit of the acceleration, it means, or it is, meter per second square. We have many concepts now. We have acceleration, we have speed, we have velocity, we have distance, time, anything like this, they are related to each other. So the acceleration is the whole one, or the biggest one. Why? Because it needs changing the speed during time. But just speed, it change just distance during time. So we have the acceleration, it's more than the speed. It's the whole meaning of the speed and the changing of the speed during time. Let's go to complete our session today. So here a formula triangle helps you to arrange the formula, a formula of the acceleration, speed, time as shown below. So we have here, this is S, A and T. The same thing. We have S, it means the speed, and we have A, it means here acceleration, and we have the T, it means time. So if I need to calculate A, I put my hand like this to what? To make V divide T. Here we have S, we have V, they are the same, okay? But in our books, we use V. Again, we use V to symbolize the speed or velocity. So here, this is V divide T, it means acceleration. So it means S divide T, it means acceleration. If I need to calculate speed, so it's what? A times T, or acceleration times time. If I need to calculate time, I have speed divide acceleration and so on. Here we have another acceleration graph to make what? To make shown this speed time graph. Here we have speed and time, and try to make it. We have 8 here and we have 4. What's meant by acceleration here? What's the acceleration? It's 2 meters per second square, mister. Thank you. It's right. Next one, we have here, this is 0. From 0 or from starting point to what? To reach what? Reach 4. And in 8 seconds, 4 meters in 8 seconds, it makes what? Makes negative 0.5, mister. Wrong. It's wrong. Like this, it's wrong. Why? Because here it is 0.5 meter per second square. Why here? Because it's increasing the speed. Next, you have another one. Here we have another different slope. So the gradient here or slope here, it means down. It moves down. It goes down. So from 8 to 0, from 8 meters, meter per second to 0 here. So it means what? 8. And 8, it means what? Which one of them? 8 divide 8. It means 1 meter per second square, mister. Wrong. Why? Because it is negative 1. Thank you. Why? Because it moves down. It means a gradient. It moves down from up to down. So we have what? We have decreasing acceleration. So we have decreasing speed. Deceleration. After that, we have this one. Mister, it's 0 meter per second square. It's wrong. Like this, it's right. Here, meter per second square is 0.1. Why? Because we have no speed here. We have 0 here. For what? For all the time, or for all periods of time. After that, we have the acceleration graph. I need to calculate, or I need to know the graph of this part. So let's start. Here we have the gradient. In this box we have the gradient of a speed time graph shown as the acceleration of an object. But what does the area underneath this speed time graph? So we have start to make this. This area under graph, the distance traveled. For example, this is for high level thinking about this. So we have this area under graph equal what? Equal distance traveled. So the distance here from what to what? From 0 to 9 seconds. No. It's from what? It's from 0 to 8 or from to 7. Next one. So here we have A and B and C. The under graph like this, we have many areas like this. And after that, we have next this area. It's have the base height like the triangle here to calculate what? To calculate the base of each one of them, or to calculate the area of each one of them. So here we have base times height equal 21, and the first one here. So we have here this triangle and this triangle. It has what? It had the same rule. It's half times base times height. So equal what? Equal half times 2 times 7 equal what? Equal 7. After that, I need to calculate whole area like this. It's in the teams questions. Okay. So we have area under graph. A plus B plus C equal 42. Is the distance traveled is equal 42 meters. It is not 7, it is not 8, it is not any one of these numbers like this, because I have what? The first one like this. This is the distance here, and we have another distance, and we have another distance here. So this area represents what? Represents 42 meters. It means distance traveled 42 meters as calculating the area under what? Under the graph or under the gradient here. So it is very important to know this one for teams question. It's high level question for you. Dear students, I hope to enjoy your time with us. I hope to enjoy your time with many examples in this session. Till we meet again in another session about speed, velocity and acceleration. Till we meet again. Thank you and goodbye everybody.